In the last tutorial, we looked at how a firm's production function, and particularly decreasing marginal products for variable inputs, affect the firm's production costs. We also said that according to this model, the firm's only goal is to maximize profits. So the material from that tutorial applies to any type of firm in any type of market. In this tutorial, we will go one step further to see how the model explains the decisions of firms specifically in perfectly competitive markets. So perfectly competitive markets are markets that fit several key assumptions. The first is that there are many small sellers and buyers in the market. So this model doesn't apply to markets where there's only one seller, a monopoly, or where there's only a few large sellers or buyers. We'll look at that type of model later in the course. The second assumption is that the goods that are sold by the sellers in the market are all identical. So there's no differences in brand, in quality, or any other characteristics between different producers. So when a buyer buys the good, they buy the same thing no matter who they buy from. The third assumption is that producers can freely enter and exit the market at any time. So if you want to start producing the goods sold in this market, you're free to do so anytime you want to. There's no barriers stopping you from entering. You're also free to stop producing anytime you want to. The last assumption is that all buyers and sellers in the market have perfect information about the good, its characteristics, its price, and whether there's profit to be made in the market. So everyone knows exactly what's going on and can make their decisions based on that information. We'll see why these assumptions are important as we go through this model and the next few models in the course. It's worth noting that this type of market is actually pretty rare in the real world. So the closest fit is the market for some agricultural products like wheat. So there are lots of small wheat producers. The wheat produced by one farmer is essentially the same as the wheat produced by any other farmer. Anyone's free to start producing wheat if they want to, and there's quite a bit of information available about the wheat market. So most non-agricultural markets don't fit these characteristics. But what we can do is use this model as a base model, and then we'll relax these assumptions later to develop some more realistic models. So each producer in a perfectly competitive market is just a very small part of the overall market. That means that the demand curve that each individual producer faces is flat or perfectly elastic. So the market demand curve is downward sloping, just like any other demand curve, but each individual producer is such a small part of that demand curve that the downward slope isn't really relevant to them. So on their own, they have no ability at all to influence the market price. What that means is that each producer can basically sell as much as they want to at the market price, but they can't sell anything at prices above the market price. So if they tried, their buyers would just go to somebody else to buy the product because everybody's selling an identical product. So each individual producer in this market is what we call a price taker. They take the market price as given when they're making their production decisions. Revenue is the total amount of money that producers earn from selling their product. Because perfectly competitive producers are price takers, they take the market price as given, their total revenue is just equal to the quantity that they sell times the market price. So here, in this example, it's equal to the quantity of bushels of corn sold times the price per bushel. So the total revenue curve is a straight upward sloping line that increases by the same amount for each additional bushel of corn that's sold. Now we can take the total revenue curve that we just saw and we can combine it with the total cost curve that we saw in the previous tutorial. So remember that the goal of the firm is to maximize total profit, which is the difference between total revenue and total cost. When total costs are higher than total revenues, total profit will be negative. When revenues are higher than costs, profit will be positive. And obviously the producer is going to operate in a range of output where profits are positive. We also want the distance between total revenue and total cost to be as big as possible, which means that we're earning the most possible profits. So remember that because marginal returns to variable inputs tend to decrease as production increases, total costs tend to increase at an increasing rate. So we established that last tutorial. What this means is that the typical cost curve will start out fairly flat. It will intersect the total revenue curve at some point, after which you're making a positive profit, and profit will increase as the total revenue curve pulls away from total costs, but eventually total costs will start increasing at an increasing rate and will start getting close to total revenue again. So what the producer wants to do to maximize their profits is produce just up to the point where the difference between those two curves is as large as possible, where revenues are as high as possible above costs. So that's basically what this model tells us about the producer's profit maximizing decision. Now, you might be thinking that producers can also reduce their costs by changing the inputs that they use, and that's something else they might want to do to maximize profits. This model actually takes that possibility into account already because it assumes that the total cost curve for a producer already represents the lowest cost combination of inputs. So there's nothing more the producer can do to increase their profits by changing inputs. You also might be thinking about models that say a producer will charge a markup above their production cost that maximizes their profits. So that may be true in markets that are not perfectly competitive, but in perfectly competitive markets, because each producer is selling an identical good, they have no ability at all to decide what price they want to sell their good at. They have to charge the market price. So the only thing they can change to influence the level of profits that they're earning is their production quantity. So that's what this model is talking about. Now on this graph, it's actually quite hard to tell exactly where the profit maximizing quantity of output is. So there's another way to look at this problem that actually makes it easier. So remember that last tutorial we also looked at marginal costs. So marginal costs are the change in total costs as you increase output by 1 unit. And we saw that because of decreasing returns, marginal costs tend to increase as you increase output. Marginal revenue is the change in total revenue as you increase output by 1 unit. For perfectly competitive markets, the marginal revenue curve is flat because each additional unit of output gets you exactly the same additional revenue, and that is the market price. So suppose that your two curves look like this. They cross at 154 bushels. For all of the bushels below that point, the producer is earning a positive profit on each additional bushel. So for example, for the 130th bushel, they're earning $4 in revenue. They have to pay $1.20 in cost to produce that additional bushel, and that gives them a marginal profit of $3.80. So for each bushel below 154, each bushel is adding to your total profit because marginal revenue is higher than marginal costs. At the 154th bushel, you make exactly 0 profit because marginal revenue and marginal costs are equal to each other. And then above that point, marginal costs are actually higher than marginal revenue. So it actually costs you more to produce each additional bushel than you would get from selling it. So what you want to do is produce right up to the point where marginal revenue and marginal costs are equal, and then you want to stop. So the profit maximizing level of corn production is 154 bushels. And if we go back to our total revenue and total cost curves, you can see that the profit maximizing level is exactly the same, 154 bushels. We're just figuring it out in a slightly different way. So the general rule for maximizing profit in a perfectly competitive market is to produce up to the point where marginal revenues equal marginal costs and then stop. So that's the quantity of production that will maximize your profit. Producing either more or less than this amount will earn you less total profit than you could earn at that point. Another way of saying this is that producers should produce up to the point where price equals marginal costs, and that's because in this type of market, marginal revenue is always equal to price. Now there's one more thing that we need to see from this marginal cost curve. So we've seen that the quantity produced, the profit maximizing quantity, is always going to be at the point where the marginal revenue curve crosses the marginal cost curve. So that point is always going to be somewhere on the marginal cost curve. If marginal revenue fell to this point, the quantity produced would also fall. And if it rose to this point, the quantity produced would rise. So because marginal revenue is equal to price, this marginal cost curve is actually showing us the quantity of output that each individual producer will produce at any given price. So in other words, the marginal cost curve for an individual producer is also the individual supply curve for that producer. So keep that point in mind because it'll be really important in the next tutorial. Now the last question is what producers should do if their total profit is negative. So we said that profit is always maximized if you produce to the point where marginal revenue equals marginal cost. But just because you're maximizing profit does not necessarily mean that you're making a positive profit. So remember that producers have fixed inputs that they always have to pay the same amount for, regardless of how much or how little they produce. So if the market price for a good happens to be low enough and fixed costs are high enough, producers might actually make a negative profit no matter how much they produce. So the best they can do, the maximum profit they can make, is still a negative profit. So in that case, they have two options. And the important thing that you have to remember here is that producers have to pay their fixed costs even if they're producing nothing. So for example, a farmer might have taken a mortgage out on their land. Whether or not they actually produce any output from that land, they still have to make their mortgage payments. So option 1 applies if producers can earn enough revenue to cover their variable costs and at least part, even if it's only a tiny bit, of their fixed costs. So that means they can pay their workers, they can buy their seeds and fertilizer, and they can pay just a little bit of their mortgage on top of that. So in that case, they should produce, and they should produce at the profit maximizing quantity, because even though they're making a loss, they're making a smaller loss than they would make otherwise, because they can cover part of their fixed costs. Option 2 applies if producers can't even earn enough to pay for their variable costs. So in that case, they would actually do better by eliminating the variable costs, producing nothing, and just paying their fixed costs. And of course, all of this only applies in the short run, as long as those fixed costs actually remain fixed. In the long run, we said before, any input is variable, so the producer could, for example, sell their land and get rid of that fixed mortgage payment. If profits are expected to remain negative in the long run, then the producer's best option is to get out of the industry entirely and eliminate those fixed costs.